Hello. In this video, we're going to look more at the transformations, and we're going to look at the horizontal transformations in this video. So for the horizontal transformations, we're going to begin with the horizontal stretches. Alrighty. So the horizontal stretch is where you take an x value and multiply it by some value when it's in parentheses. And so y equals f of bx would be something that happens like that. So if b is greater than 1, then the graph of y equals f of b of x is let me get the right pen here, horizontal shrink of the graph of y equals f of x by a factor of b. Now, whenever I say this, we have to be very careful. Notice that, notice that y equals f of bx, where b is greater than 1, this is a horizontal shrink, whereas with vertical transformations, if a was greater than 1, then it would be a vertical stretch. So it's actually a little bit the opposite, and that's the reason why is because if it's affecting the x value, not the y value itself, then you do the opposite of what it says. So if it says multiply by b here, technically we're dividing. So if we're dividing by a number greater than 1, then we are getting smaller. So this is actually a horizontal shrink. An example of this would be the following. Let's say we have y equals, let's say parentheses 2x all cubed. And in this case, that means that this 2 is a horizontal stretch by a factor of, a horizontal shrink by a factor of 2. As for the next one, let's go ahead and assume that that's a capital I there. If 0 is less than b is less than 1, then the graph of y equals f of b times x is a horizontal stretch of the graph of y equals f of x by a factor of b. Excellent. Now, what we mean by this is if 0 less than b is less than 1, if b is a number between 0 and 1, then we are actually getting larger because we're dividing by a number between 0 and 1. And when you do that, you actually get larger, which is the reason it's a stretch. As an example, we would have something like this. Y equals 1/2 x all cubed. And in this case, that would be 1/2. So technically, it's a factor of 2 in this case that we'd actually get larger because we're actually dividing by 2. Excuse me, we are dividing by 1/2, which is the same thing as multiplying by 2. Okay, as for the horizontal shift, let's work with purple here. The horizontal shift looks like this. Notice that x plus h is on the inside of the parentheses there. So y equals f of x plus h shifts the graph of y equals f of x left h units. An example of this would be y equals the square root of x plus 2. So that plus 2 would shift the parent function of square root of x left 2 units. Notice it's the opposite because it's inside with the x. So it's inside this big radical with the x, therefore you have to do the opposite. So anytime it's in the parentheses with the x, you do the opposite. Always remember that. For the next one, y equals f of x minus h, it shifts the graph of y equals f of x right h units. And an example of this would be y equals the square root of x minus 2. And notice that we always do the opposite. Alrighty. As for my math lab is going to only want horizontal stretches. And on the horizontal shifts, it could be either one or the other, but they're only called shifts. Okay, so it's not technically left or right, it's just horizontal shift, and if it moves left, you just say -2, and if it moves right, you say +2. And I'll show you more about that whenever we get to it. Alrighty. Well, I believe that that's it for this particular video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.